Hi everyone, and welcome to this math webinar in which we're going to be reviewing some core subjects and concepts that come up on algebra related questions on the SAT and on the ACT. So we're going to have lots of fun reviewing fractions, combining units, fundamentals from algebra, factoring, exponents, radicals, f of x, linear systems, and sequences, right? We've got a lot on our plate. We're going to do usually about 2 questions for each section. We do have some sections where we do some extra example questions when they're tested more frequently, or maybe have some nuanced rules where we really need to make sure that you get a great review. So really excited to take you through this presentation of all of these questions coming from past real tests from the past year. So everything is super fresh, super relevant, and let's go ahead and get started with fractions. In this segment on fractions, we're going to go over 5 of the very frequently tested question types in which you need to have knowledge of rules about fractions to be able to solve. Now keep in mind that most fractions questions tend to be more in the easy and medium sections of the ACT and the SAT. So let's go ahead and jump into our first question. And the first thing I want you to notice is that as a word problem, right, there's kind of a lot of words here. So keep in mind that it's always a good idea to take notes as you read. So we have that Jasmine and Keon are painting a room in the city hall. They started with 7 gallons of paint. Okay, so that's what they have to start. On the first day, so this is where I'm going to take some notes. So Jasmine used half a gallon and Keon used 1 1/4 gallons of paint. How many gallons of paint were left when they completed their first day of painting? So we're going to have to start with the 7 gallons that they had in the beginning, take away the half a gallon that Jasmine used, take away the 1 1/4 gallons that Keon used, and see how much we have left. So the first thing I want to do is convert Keon from 1 1/4 to be just a single fraction. So remember that what you're going to do is you do 4 times 1, so you do a multiplication there. 4 times 1 is 4, and then we do plus what's in the top, which is plus 1. So 4 times 1 is 4, plus 1 is 5 on top, and then we keep the denominator the same. So 1 1/4 is the same thing as 5/4. So now let's try to add Jasmine plus Keon together. That will be 1/2 plus 5/4. Now we have this perfect opportunity to review how do we add fractions. And remember that for us to be able to add fractions, they have to have the same denominator. So this 2, I'm going to need to change to have a 4 on the bottom, because 4 is going to be the smallest number that both 2 and 4 go into. So what I'm going to have to do is to get from 2 to 4, I multiply by 2. So whatever I do to the bottom, I have to do to the top. So that means that 1/2 is the same thing as 1 times 2 for the top, which is 2/4, plus 5/4. Now remember, when we add fractions, the reason we get the denominator to be the same is that it stays, and then we combine the top. So when all of this is said and done, Jasmine and Keon together used up 7/4 gallons of paint. So now the question becomes, well, if they started with 7 and we need to take away 7/4, that's going to be our last operation to solve this question. So we have 7 gallons of paint to start minus the 7/4 gallons that were used. Remember that we have to get a common denominator. So right now we have 7/1. We don't want a 1 on the bottom, right? We want it to match and have that 4, because 4 is the smallest number that 1 and 4 go into. So I'm going to multiply 4 on the bottom. Remember, whatever you do to the bottom, you have to do to the top. So 7/1 is the same thing as 7 times 4, which is 28, over 1 times 4, which is 4. So again, 7 is just converted to be 28/4, which is the exact same thing of 7. Now we can subtract 7/4. We get 28 minus 7/4, which is 21/4. Now one final step as we look at our answer choices, right? We have to now convert 21/4 to be a whole number kind of plus that fraction. So I want you to think to yourself, 4 goes into 21 how many times? And 4 times 5 is going to be 20, but then we have 1 left over to get to 21, which means that 21 over 4 is the same thing as 5 1/4. So the correct answer is going to be E. All right, moving on to our next question. This one's actually a little bit easier, has fewer steps than the one we just did. So they're telling us that A is 2, B is 3, and C is 8. So if we want to know what does A over B squared plus C over 2 equal, basically what we're going to do is we're going to take that A equals 2, plug it in there. We're going to take that B equals 3, plug it in there, and that C equals 8, and plug it in there. So let's see what we end up with. We end up with 2 on top over 3 squared plus 8 over 2. So that's the same thing as 2 over 9, right? I changed that 3 squared to a 9, plus 8 over 2. So for us to add these fractions together, remember we have to find out what's the smallest number that they both go into, which is going to be 18. So with the 9 to get to an 18, we're going to multiply by 2. And from the 2 to get to an 18, we're going to multiply by 9. So now we can simplify. We've got 2 times 2 is 4 on top. 9 times 2 is 18. That means 2 over 9 is the same thing as 4 over 18. Plus 8 times 9 is 72 over 2 times 9, which is 18. Remember, the whole reason we get a common denominator is so that it stays the same and we can combine the top. 4 plus 72 is 76. Then we have over 18. Now, if we look at our answer choices, it looks like we're going to have to simplify this a little bit further. So what I want you to think about is what can I divide both the top and the bottom by? I always like to start with 2 to see if they're both divisible by 2. Do that. Are they both divisible by 3? Do that and kind of continue in that way. So they are both divisible by 2. 76 divided by 2 is 38. 18 divided by 2 is 9. So our answer is 38 over 9, which is option C. So again, for that one, we had to know those basics of how to add fractions, but there was kind of the extra part where we had to make sure we were putting the numbers in the right place. All right, our third fractions question. So the first thing I'm going to do here is just rewrite it for you. So we've got 15x squared plus 25x divided by 5x. Now what makes this question difficult is that most students forget how to separate out when you're adding on top or subtracting on top, and then you have kind of one thing like 5x on the bottom. So what I want you to do is break it up into 2 parts. So the first thing I'm going to do is I'm going to do the 15x squared over 5x plus, and then for our second part, I'm going to rewrite it where again I put that denominator to both parts that are in the top. So what we end up with here is, again, we took this single fraction, how we were adding on top, and we've separated it by preserving the denominator in both parts. That 5x is the same on the bottom of both. And now we can simplify each part. So the 15 over 5, I can simplify to be 3 over 1. X squared over x, remember, if you have the same base on the top and the bottom, this x is kind of like x to the 1 because there's an invisible 1 there. And if you are dividing them and they have the same base, remember we subtract the exponents. So we end up with 3x to the power of 2 minus 1, which of course is going to be 3x because x to the power of 2 minus 1 is just x to the 1. So our first part is going to be 3x plus, how do we simplify 25x divided by 5x? Our x's cancel as 1 over 1. 25 divided by 5 is 5 over 1. So 3x plus 5 is our final answer. So when we have simplified, again, the hard part of this question was knowing that initial step that you had to take that 5x, put it to the first part, and put it to the second part. Once we separated it out, it was much easier to cancel. Speaking of canceling, For this next question, great review, right, of how when you have the same number on the top and the same number on the bottom, you can cancel them when you're multiplying, of course. So we've got a 4 on top. I'm going to get rid of the 4 on the bottom. 5 and 5, 6 and 6, 7, 7, oops, sorry, crossed out the wrong one, 7, 7, 8, 8. So what am I left with here? I'm left with 1 times 2 times 3 on top, and I'm left with 9 times 10 times n on the bottom. So let's do another round of simplifying here. 2 over 10, I can simplify to be a 1 on top and a 5 on the bottom. 3 over 9, 3 goes into 9 3 times, so I can cancel the 3 over 9, and that's the same thing as 1 over 3. So now, how do we simplify? Well, remember, we just multiply across, so on the top, we basically end up with 1 times 1 times 1. On the bottom, we end up with 3 times 5 times n. So we end up with 1 on top. 3 times 5 is 15. So 1 over 15n is our final answer, which is option D. Now our last question to review fractions, again, we had more of these because it's tested frequently, and the other thing about fractions is they tend to sneak their way into other question types. So you definitely need to know all of these core rules for fractions. So the first thing we're going to look at here, and again, I'm going to just rewrite what we're solving. So we have 3x minus y over x plus y equals 4 over 7. Now what you have to know to solve this problem correctly is how when you have a fraction equals a fraction, your brain needs to go to, oh yeah, I need to cross multiply and solve. So what you're going to do is you're going to cross multiply here. So we're going to end up with 7 times 3x minus y equals, then we're going to cross multiply here, 4 times x plus y. Now let's be very careful with our distribution. So remember, we're going to do 7 times 3x is 21x. 7 times negative y is minus 7y equals, make sure you're careful again with your distribution, 4 times x is 4x. 4 times positive y is plus 4y. Now remember, the question is asking us to find x divided by y. So what I'm going to do first is kind of get all my x's together, all my y's together, and then I can move the y over to be with the x. So first thing I'm going to do, get this 4x to the other side. Again, I'm trying to get my x's together and my y's together. 21x minus 4x is 17x minus 7y equals 4y. Next step is to get my y's together because I'm subtracting 7y on the left. I'm going to bring it to the right by doing the opposite and adding 7y. So they cancel on the left. I'm left with 17x equals 4y plus 7y, which is 11y. Now remember, I'm trying to get x divided by y. So the next thing I'm going to do is divide by y on both sides. I'm going to kind of bring this over here to have a little more room. So I'm left with 17x divided by y equals, remember when I divide by y they cancel on that other side, it equals 11. So my last step to get x divided by y alone is because I am multiplying by 17 on the left side. I'm going to do the opposite and divide by 17 on both sides. So that will cancel. I'm left with x over y equals 11 over 17. And the right answer is C. So these questions all brought together some super key rules for fractions, right? Knowing how to combine them by getting a common denominator, knowing how to split them up when you need to, knowing how to cross multiply and solve. So some great just fundamentals with fractions were reviewed in these questions. To review the concept of combining units, which we see a ton on the SAT and the ACT, we're going to do two questions together, one that's on the easier side and one that's a little bit more advanced. So let's go ahead and jump in and make sure that you're comfortable with this concept of how to move around information to be able to solve for missing variables. So first thing I'm going to do is rewrite what they've given to us. So I have 3x minus 9 equals 5x minus 15. Remember, my goal here is to solve for x. So to solve for x, I need to get all my numbers together and I need to get everything with an x together. So again, I'm combining things that are similar to each other. So the first thing I'm going to do is subtract 3x from both sides. Think about, I could have subtracted 5x from both sides, but then the reason I didn't do that is that on the left side, I would have had 3x minus 5x, and I would have ended up with a negative number in front of the x. So just to try to avoid possibly complicating things by ending up introducing negative numbers, that's why I'm kind of choosing to bring the x from the left to the right side, again, so I can keep that value positive. So 3x minus 3x on the left is going to cancel. I'm left with negative 9 equals 5x minus 3x, which is 2x minus 15. Next, to get my x alone, right now we are subtracting 15, so I'm going to do the opposite and I'm going to add 15. Cancels on the right. Negative 9 plus 15. Quick note, if you are working in a math section where you're allowed to use a calculator, right, on the SAT there is a non-calculator portion, and then of course the calculator portion. The ACT, you do get a calculator the whole time, but I just wanted to give a quick note that if you need to use a calculator, and again you're in a section where it's allowed, feel free to do things like negative 9 plus 15. Right? There's no shame in that. If your brain kind of plays tricks on you, especially with negative numbers, don't stress yourself out. Just use the calculator. So negative 9 plus 15 equals 6. So 6 equals 2x. Last thing to solve for x is being multiplied by 2, so I have to do the opposite and divide by 2. That way it will cancel on that right side, and I'm left with x equals 6 over 2, which is 3. So I have now solved this question that x equals 3, so the correct answer is E. Now for this next question, we're going to apply the same principles of how you kind of get the terms with x's together and the numbers together and how do we solve for x, but it'll be a little bit more challenging. So what they're asking us here actually is to solve for x plus y. So if we look, we have our first equation which has an x variable and our second equation which has a y variable. So we're going to solve the first one for x, solve the second one for y, but then we have this kind of final step where then we have to take those two values and add them together. So let's start by solving for x. We know that 3x plus 4 equals 6. We want to get x by itself. Because we're adding 4, I'm going to do the opposite and subtract 4. I'm left with 3x equals 2. Last step, because x is being multiplied by 3, I'm going to do the opposite and divide by 3. And I get that x equals 2/3. Lucky us, it looks like we're going to have some fractions coming our way when we add x plus y, so that'll be great. We'll do a little bit more review of that. Okay, let's now solve for y. We know that 2y plus 7 equals 6. Let's get y by itself. Because I'm adding 7, I'm going to subtract 7. So I have 2y equals 6 minus 7. Again, if you need a calculator, no worries. It's negative 1. Last step, because y is being multiplied by 2, I'm going to do the opposite, divide by 2 on both sides, and I'm left with y equals negative 1/2. My last step is to add x plus y together and see what that equals, because that's going to be my answer. X was 2/3 plus y was negative 1/2. Again, I want to add those together. So 2/3 plus negative 1/2 is the same thing as 2/3 minus 1/2. Now, remember if you did the review, right, for fractions, for us to be able to combine fractions by adding or subtracting them, we have to get a common denominator. So what is the smallest number that 3 and 2 both go into? And it's 6. So I'm going to rewrite, again, where I'm going to now need to figure out what's the numerator for each one, and then I'm going to subtract it. So how do I get from 3 to 6? I'm going to multiply by 2, so I do the same thing to the top as I do to the bottom. 2 times 2 becomes 4. How do I get from 2 to 6? I multiply by 3. Whatever I do to the bottom, I do to the top, and 1 times 3 is 3. So I now have 4 over 6 minus 3 over 6. Remember, the whole reason you get a common denominator is so that it stays the same, and then you can combine the top to be 4 minus 3. So our answer is 1 over 6. So it looks like B is going to be the correct answer. Again, combining units is something that you can see throughout an entire math section, right? Even a question that's not explicitly testing you on combining units could still require that you know these core foundations. So that's why it's so critical to review, because again, even if you end up with negative numbers or you end up with fractions, it's easy to make mistakes. So we just want to make sure that you're really comfortable moving around information to solve for variables. From Algebra Fundamentals, we'll see questions about things like a least common multiple, negative signs, order of operations, absolute value. So these next two questions are going to, again, capture those types of concepts so that we can review them together. So let's go ahead and jump in. The first question says, what is the least common denominator of these three fractions? So the first thing I want you to know is, what is the least common denominator? So that is going to be the smallest number that 14, 20, and 8 all go into. So again, I know it took me a second to write that down, but I really want to make sure you have this clearly in your notes. What is the least common denominator? It is the smallest number that 14, 20, and 8 will all go into. So one approach to solve a question like this is to go straight to the answer choices and to see, can you do 56 divided by 14 evenly? Can you do 56 divided by 20 and 56 divided by 8? Right? We've checked our first option of A. If it doesn't work, or when it doesn't work, you could then try B. Can you do 168 divided by 14, 168 divided by 20, etc.? And you could just keep going until you find the smallest number that they all go into. Now, the other way to do it, which is the way I'm going to show you, is how to actually solve it algebraically. Again, you can use that trick by testing the answer choices, but I do want to make sure that we review how to do prime factorization, because that is how you will actually find the smallest number that they all go into, which is also called the least common multiple. So what we're going to do is we're going to start with 14, and I'm going to do my prime factorization. Now, first thing I want you to remember, the number 1 is not prime. Okay, that's another thing that's really important to take away from this question. The number 1 is not prime. A lot of people make the mistake of thinking that 1 is the smallest prime number. 2 is the smallest prime number. So let me write that down for you. 2 is the smallest prime number. All right, so when we're doing our prime factorization of 14, what I always want to start with, if I can, is start with a 2. And I can do 14 divided by 2, which is 7. Now 2 is a prime number, 7 is a prime number, which means I am done with my prime factorization of 14. I know that to get 14, I have to have a 2 and I have to have a 7. Now let's do the same thing with 20. Again, always start with 2, our smallest prime number. 20 is 2 times 10. 10 is 2 times 5. Can't go any further, right? Because those are now all prime numbers. So to have a 20 go into something, I need a 2, and a 5. Last one is 8. To get 8, I have a 2 and a 4, and a 4 is the same thing as 2 and 2. So to get an 8, I have to have 3 2's. So now that I know all the prime factors for these three numbers, what I can do is now basically create, okay, well, what's the smallest number that they're all going to go into? Well, for 8 to go into it, I have to have 3 2's. So the first thing I'm going to do is write that I have to have a 2 3 times, right? That will take care of these 3 numbers that are needed to get an 8. Now, if we look at 20, a 20 needs 2 2's. Well, guess what? I already have 2 2's ready to go. I have an extra one, right, which I needed for 8. So I don't need to rewrite those 2 2's because, again, they're already captured. But I do not have a 5, so I need to add a 5 to what I'm kind of creating here as the smallest number they're all going to go into. Now, lastly, let's check 14. 14 needs 1 2. I already have a 2, but I do not yet have a 7, so I'm going to need to add a 7. And that will take care of that. So basically now when we think about it, I've got my 3 2's to make sure that 8 will go into it. I have 2 2's and a 5 to make sure that 20 will go into it. and I have a 2 and a 7 to make sure that 14 will go into it. So I now know that when I do 2 times 2 times 2 times 5 times 7, which by the way is 280, that is going to be the smallest number that they all go into. So great question here because we got to review prime factorization, we got to review some basics of prime, and of course we also got to review the least common denominator. And the least common denominator of 3 fractions is basically finding the least common multiple of the 3 denominators. Okay, so for our next algebra fundamentals question, again, we just get to go over some great rules. So it looks like first we're going to get to go over a rule about absolute value. So I have absolute value of -2 minus 3 quantity squared, plus I have a negative number to an odd power of 5, so we're going to get to review that. Plus in the bottom, we're going to get to review order of operations. We have 16 divided by 4 times 2 minus 4. So what order are we going to do everything? Okay, so let's start with our absolute value on top. -2 minus 3 is -5, so I'm going to have the absolute value of -5 quantity squared plus -1 to the power of 5. Now remember, a negative number raised to an even power, like 2 or 4, would become positive. A negative number raised to an odd power, like 3 or 5 or 1, is going to keep its negative number. And make sure too, by the way, that if you're using a calculator, do not write -1 to the power of 5, because order of operations, it'll do 1 to the power of 5 first and then multiply by -1. You have to use parentheses, -1 to the power of 5. Again, if you don't put that -1 in parentheses, you're going to get the wrong answer in your calculator. Okay, so -1 to the power of 5 is going to stay -1 all over 16 divided by 4, which is 4. 4 times 2 is 8. So I'm going to have 8 minus 4 on the bottom. So notice that I just kind of combined that first section going straight across from left to right. 16 divided by 4 is 4. 4 times 2 is 8. Then I'm going to do the minus last. So that's why I rewrote it as 8 minus 4. All right, next step, absolute value of -5. What does that actually mean? So here's -5 and here's 0 on a number line. Absolute value is defined as the distance between that number and 0. And guess what? If something is a distance, distance is always positive, which is why the absolute value of -5 is 5. So I'm going to have 5 squared plus -1 just becomes -1 over 8 minus 4, which is 4. So my last step, 5 squared is 25. 25 minus 1 over 4. That becomes 24 over 4, which is 6. So the correct answer is E. So again, for algebra fundamentals, it's really important that you know basic stuff about prime factorization, about negative numbers being raised to powers, about absolute value, about squaring, about PEMDAS, our order of operations, right? All of those really important concepts can show up in these types of questions that are pulling at your knowledge of all of those different things all wrapped up into one question. For factoring, we're going to do 3 questions together that are going to progress from kind of a medium level difficulty to a hard level difficulty. So let's start with our first one, which is a medium. What is the sum of the 2 solutions of this equation? So remember, anytime they ask you for solutions, what does that mean? So solutions are going to be values of x that make the expression true. So it's basically asking what can we plug in for x in those spots so that when you square the x and then subtract when you've multiplied it by 3 and then subtract 54 that it equals 0. Right? Basically, what can we put in there for x where that equation will be true? So what you have to remember when you're doing, when you're solving and looking for solutions from quadratic equations, I'm going to rewrite it for us really quickly, is that we need to look for, okay, what numbers multiply to negative 54 and add to negative 3. So in my mind, what I do is I think, okay, what multiplies to 54 and has a difference of 3, right? Because the negative sign I can take care of really easily, right? If I have a negative sign, I know one's positive and one's negative. If I have a positive sign, I know that they're either both positive or both negative. So again, that's how factoring can become a bit more challenging. But the core foundations that you need, right, are that this coefficient at the end, kind of the C term, right, is where we generate that from multiplying. And then this term that's in front of the X is how we add them together to get that number. So I know that 9 and 6 multiply to 54 and have a difference of 3. So I'm liking that, right? Because chances are these are going to be my numbers, but now I have to figure out which one's positive and which one's negative. Well, if when I add them together, it's still a negative number, it has to be negative 3 when I add them together, then I know that I need a negative 9 and a positive 6. So now I can double check. Negative 9 times positive 6 is negative 54. That's what we wanted. And negative 9 plus 6 is negative 3, which is what we wanted. So now that I'm ready to factor, I'm going to take those numbers, and I know that x squared minus 3x minus 54 is the same thing as x minus 9 times x plus 6. And remember, those equal 0. Don't forget about the equal 0 part. Because now to be able to get our solutions, which remember is what we're supposed to do, I'm going to separate this into two parts. I know that x minus 9 equals 0, and I know that x plus 6 equals 0. I'm going to add 9 to both sides to solve, and I get that x equals 9. Because I'm adding 6, I'm going to subtract 6 from both sides to solve. So I end up with x equals 9 and x equals negative 6. Now the question is asking me to find the sum of those two solutions, which means I have to add them together. So the sum of the two together will be 9 plus negative 6, which is the same thing as 9 minus 6, which is 3. So the correct answer to this question is that we first had to factor so that we could find our solutions, and then there was that kind of extra step of having to actually find the sum of the two solutions by adding them together. Okay, so this next question, we're going to do something very similar to what we did on the last one, but there's kind of this elevated challenge because when I look at it for the first time, right, in this question, I had an x squared and then I had an x. But over here, I've got x to the 4th and then x squared, which is where a lot of students start to panic, but you actually don't need to. So if this question was x squared plus 7x minus 144 equals 0, notice that we could jump straight into factoring, right? And the reason is that this number squared is this number, right? X squared is x squared, so that's how we knew that we could factor it. Well, we have the exact same thing here. X squared, if we square it, becomes x to the 4th. So all that we have to do when we factor is instead of having an x plus or an x minus, we have an x squared and an x squared. So again, the challenge here is recognizing that you are allowed to factor this expression. And what kind of we can do is thinking about, okay, well, how can I get x to the 4th? I get x to the 4th with x times x cubed, with x squared times x squared. You always want to jump to the x squared and x squared because there's a 99% chance that that's going to be the right answer, especially on a standardized test. Unless, of course, you're taking a test at school where they're challenging you on kind of more complicated applications of how to factor when you have powers higher than 2. So now that I know, okay, over here I would have had an x and an x, but now I know that I just have an x squared and an x squared, we can do the rest of it exactly the same, which is thinking to ourselves, okay, what multiplies to negative 144 and adds together to positive 7? Now, I know that 16 and 9 will multiply to be 144, and they also have a difference of 7. So I'm going to use 16 and 9 for my answers, but again, I have to figure out which one's positive and which one's negative, because when they multiply, it's a negative number, but when we add them together, it's a positive number. So if we add them together and we want it to be positive, that means that 16 has to be the positive one and 9 has to be the negative one, because again, when I add them together, it should still be a positive number. And if I did the reverse, if 16 was negative and I added 9, I would still have a negative number. So I've now figured out that I need to put a plus 16 here, and I need a minus 9 here, and do not forget that they still equal 0. Now, just as we did in the prior question, I'm going to separate it out into two parts. I have that x squared plus 16 equals 0, and I have x squared minus 9 equals 0. So what I'm going to do is, again, I'm trying to solve for x here. So I'm going to subtract 16 from both sides. I get x squared equals negative 16. Now, to solve for x, because I'm squaring it, I have to do the opposite and take the square root of both sides. So now, remember, if you start with a squared and take a square root, your answer is going to be plus or minus the square root of negative 16. Now, to solve for the square root of a negative, remember, square root of negative 16 is the same thing as the square root of 16 times the square root of negative 1. So we're going to end up with x equals plus or minus root 16 is 4, and the square root of negative 1 is I. So our first answer that we were able to solve from kind of the x squared plus 16 equals 0 is that our answer is going to have a positive 4i and a negative 4i. Now to solve this other part, it's going to be a little easier for us. So x squared minus 9 equals 0. We can add 9 to both sides. I'm going to bring it over to the right a little bit. X squared equals 9. To solve for x, we just take the square root of both sides. And remember, if you start with a squared and then you take the square root, you're going to have two answers, a plus and a minus. So the square root of x squared is x equals plus or minus root 9. So x equals plus or minus 3. So we will have 4 answers, which makes sense because we have it to the 4th power. We're going to have a positive 3, a negative 3, a positive 4i, and a negative 4i. So the correct answer is D. All right, let's do one more factoring question. It's also going to combine some review of how do we combine fractions. So really good to get that kind of extra practice. This question, by the way, was the last one in a section. This is the hardest question that you could ever possibly see about factoring. Okay, so here we go. First thing I want to think about is how do I simplify my denominators? So they're both quadratics, right? And so we want to take them down so that we have things that look like this, right, with an x and an x, so that again, we're breaking them down into their factors. We're getting them down into kind of their smallest parts. So x squared minus 9, remember, is the same thing as x squared plus 0x minus 9. So one way to think about it is to remember right away, oh, if I have x squared minus and then a perfect square like 9 or 16 or 25, you can automatically know that that's the same thing as x plus 3 times x minus 3. Or you can go through the process of thinking about factoring and what multiplies to negative 9 and has a difference of 0. If they have a difference of 0, they have to be the same number, right? That's why we end up with 3 and 3. And then, of course, one is positive and one is negative because they multiply to negative 9. Okay, so when I rewrite my first part, I'm going to have 5 over x plus 3 times x minus 3 plus 6 over, now how do I factor x squared plus 3x minus 18? Well, we're going to have an x and an x, and remember, we have to think to ourselves what multiplies to 18 or to negative 18 and has a difference of 3. Well, 6 and 3 will multiply to 18 with a difference of 3, and if we want them, when we add them together, to be positive, I'm going to have a plus 6 and a minus 3. So let's just double check. If I multiply 6 times negative 3, perfect, I get negative 18. If I add them together, 6 plus negative 3 is 6 minus 3, which is positive 3. Okay, so that means that my denominator, when I rewrite over here after factoring, is x plus 6 times x minus 3. Now, our review of combining fractions when we want to add them together is, of course, that we have to have the same denominator. So if I think to myself, okay, how can I go from what I, currently have, but make sure that I have every part that I need? Well, if I look at my total number of expressions, I've got an x plus 3, I've got an x minus 3 in both, and then I have an x plus 6. That means that my common denominator with these two fractions is going to be x plus 3, x minus 3, and an x plus 6. So again, I'm going to write that out for both pieces, and then we'll review how do we get that and how do we need to simplify. So we already had an x plus 3 and an x minus 3 on the left, right? Here they are. But we are missing an x plus 6. So if I want to multiply the bottom by x plus 6, I'm going to have to multiply the top by x plus 6. So on the top, I end up with 5 times x plus 6. Now let's do the same thing for the second one. I have an x plus 6 already. I have an x minus 3 already. I am missing an x plus 3. So whatever I do to the bottom, I have to do to the top, and I'm going to simplify this as 6 times x plus 3. Now remember, the whole reason that we get the denominators to be the same is so that we can combine the fractions. And then we also have to be very careful that we properly distribute the 5 to the x, the 5 to the 6, and same thing over here with the 6 to both parts. So in my numerator, 5 times x is 5x, 5 times positive 6 is plus 30, over, I'm just going to put little tick marks because instead of rewriting the whole thing, I'm just going to remember that the denominator stays the same. Plus 6 times x is 6x, plus 6 times 3 is 18 over the same thing. So now, remember, we can keep the denominator the same. X plus 3 times x minus 3 times x plus 6. And how do we simplify our numerator? 5x plus 6x is 11x, 30 plus 18 is plus 48. So all of that work, here is our final answer, 11x plus 48 over all three of those fractional parts, right? All three of those factors, because again, when we created our least common denominator, right, what is the smallest thing that they would all go into, we had to first factor so that we could see their smaller parts and then figure out how to combine them together. To review exponents, we're going to do two questions together. One's easy, one's hard. And in the process, we're going to make sure that we really review how do we combine exponents, right? Are we supposed to add them? Are we supposed to multiply them? Are we supposed to subtract them? It's confusing, right? It's an easy place to make a mistake, but these concepts are straightforward, so you need to just know the rules so that you can apply them properly. So the first thing to know for this question is, remember, if you kind of have these back-to-back parentheses, what you're doing in between is multiplying. Sorry, that was a weird looking multiply. So that means that when I'm multiplying, I'm basically going to have x to the 5th times x cubed, that expression, y to the 4th times y cubed, and then z cubed, z to the 6th. Now remember, let's do a quick review of our rules. If I have x to the 5th times x cubed, then what do? I add the exponents, 5 plus 3. If I had x to the 5th divided by x cubed, what would I do is if I'm dividing, I subtract the exponents. And last thing to review, if I had x to the 5th raised to the power of 3, so a power to a power, I multiply the exponents. So this review right here basically takes us through a summary of what do I do with the powers? Do I add them? Do I subtract them? Do I multiply them? So great, just kind of little summary there on the side. This question is only asking us about this top part, which is when we are multiplying, what do we do with our exponents? But I did want to still review kind of what to do in the other two circumstances just to make sure your notes are thorough. Okay, so x to the 5th times x cubed, as we just reviewed, we're going to add our exponents, x to the power of 5 plus 3. Y to the 4th times y cubed becomes y to the power of 4 plus 3. Z cubed times z to the 6th becomes z to the power of 3 plus 6. So our final answer is going to be x to the 8th times y to the 7th times z to the 9th, which looks like option A. Let's just double check. X to the 8 is right, y to the 7, z to the 9, perfect. A is the correct answer. So our next exponents question is much more challenging. So we're going to get to review in this question a core rule that if you ever have something to a power equals a number, right, which we have in that first part and in the second part, your number one job is to try to have the same base on both sides. So instead of having 36 to the power of a equals 6, I want you thinking, how can I change a 36 so that it also has a base of 6? And hopefully what you remember is that 36 is the same thing as 6 squared. So if 36 is the same thing as 6 squared, I'm just going to change that 36 to be a 6 squared, and then I'm still going to raise it to the power of a, and that equals 6. Now, as we reviewed on that prior question, if I have a power to a power, what do I do with the 2 and the a? I multiply them together. So 6 squared raised to the power of a is the same thing as 6 to the power of 2 times a is going to equal 6. And remember, 6, by the way, is the same thing as 6 to the power of 1. Now, once our bases are the same, the power of that is that I can set the exponents equal to each other to solve. So 2 times a is 2a, and 2a equals 1. Divide both sides by 2, and I get a equals 1/2. Now let's look at our other part. We have 3 to the power of a plus b equals 81. Now some of you might be thinking, oh, I know what a is, it's 1/2. And yes, you could at this point substitute it, but actually what I would encourage you to do is before you substitute for a, let's focus on that initial critical step. How do I get the same bases on both sides? So I know that 3 to the power of a plus b equals, remember, 81 is the same thing as 3 to the power of 4. So now that I have the same bases on both sides, what can I do? Well, I know now that their exponents are equal to each other. So I can now write that a plus b equals 4. Now I can replace that a. A is 1/2 plus b equals 4. Notice a question that's not even supposed to be about fractions is now about fractions, right? Fractions are going to sneak their way everywhere. Because to solve for b, I'm adding 1/2, I'm going to do the opposite and subtract by 1/2 on both sides. I get that b equals 4 minus 1/2. I'm going to bring this over here so I can finish solving. So b equals 4, which is the same thing as 4 over 1, minus 1/2. Remember that for me to be able to combine those fractions, I need to have the same denominator. The smallest number that 1 and 2 will both go into is 2. How do I get from 1 to 2? I multiply by 2, so I have to do the same thing on the top and the bottom. 4 times 2 is 8. So 4 over 1 is the same thing as 8 over 2 minus 1/2. The reason we get the denominators the same is so that they stay the same, so that 2 stays on the bottom, and I can combine the top. 8 minus 1. My answer is 7 over 2 is going to be the value of b, so the correct answer is E. So again, for these exponents, core things you need to know. First, what am I supposed to do with the exponents, right? Am I supposed to, and I'm going to kind of put this over here again with another color just to make sure you're really reviewing. Main takeaways here are making sure you review the rules for when you're supposed to add, subtract, or multiply the exponents based on what you're being asked to do. And then, of course, also remembering the core rule that when you have numbers, on either side that are set equal to each other, your job is to get them to have the same base on both sides. So get those bases the same and then know the rules for exponents for what you're supposed to do, whether you're supposed to multiply them, subtract them, or add them. To review radicals, we're going to do 2 questions together. One came from the medium section of difficulty, the other came from the hard. Now, before we do this question, I want to just pause for a second and review a core rule that comes up all the time on the SAT and on the ACT with respect to radicals. And that is that you need to know how to rewrite things from a radical form to an exponential form. So what does that mean? That basically means that you need to be able to take the square root of x and know that that's the same thing as x to the power of 1/2. That means that you need to take something like the cube root of x to the 4th, and you need to know immediately that that's the same thing as x to the power of 4/3. Now let me teach you how to know this and to remember it so that it's easy for you. My brain always goes back to memorizing that square root is the same thing as to the 1/2 power. And then the way that you can remember what number goes where is x is the same thing as x to the 1, and square root is the same thing as having an invisible 2 on the outside. So this 2 on the outside goes to the bottom. I always remember that the outside one goes to the bottom. So if I have the cube root of x to the 4th, students will always stress out, oh my gosh, is that x to the 4/3 or x to the 3/4? I can't remember where to put which number. Just remember the one on the outside goes to the bottom. So similarly, if I had asked you, what is the 4th root of x to the 5th? You would know that that's x to the power of, and then which one goes on top and which one goes on the bottom. Remember, the one on the outside goes to the bottom, so the 4 goes to the bottom, and the inside goes to the top. Again, if you don't remember which one goes where, you can use your your square root of x is x to the 1/2 to always remember that the one on the outside of the radical goes to the bottom when you have it as a fraction in the exponent. Okay, so I know that that was kind of a little bit of review. Now we can solve this question. So this question is asking us, what is the cube root of 64x to the 9th? Now, because we are multiplying under the radical, I want to make sure that you know that you can separate this. And this is the same thing as the cube root of 64 times the cube root of x to the 9th. Well, the cube root of 64 is 4, right? You could also have done over here, if it's helpful, 64 to the 1/3 power, if that's easier for you to solve in your calculator than doing the cube root. How do we rewrite the cube root of x to the 9th? Well, remember that's going to be x to the power of, the one on the outside goes to the bottom, the one on the inside goes to the top. X to the power of 9/3, 9 divided by 3 is just 3. So we have 4 times x cubed is our answer, which is option A. So a couple things for that question. First, you definitely have to be super comfortable rewriting when you have a radical versus when you have a fraction in the exponent. That is critical. Number 2, I want to make sure that you remember that if you are multiplying or dividing under a radical, so let's say, for example, we had the cube root of 64 divided by x to the 9th, you could rewrite that as the cube root of 64 divided by the cube root of x to the 9th. So when you are multiplying or dividing under a radical sign, you are allowed to separate it. So I separated it here because it was being multiplied under the radical, and I separated it here because it was being divided under the radical. So lots of great rules here from this initial radicals question, but we do have one more. And it was actually the last question in a section. So it was the hardest math question that was asked in a section. And basically they want us to rewrite x to the 1/2 times y to the 4/3. How do we put that? How do we combine that into a single radical form? Right? If you look at all of our answer choices, they're all just one combined radical where we've put the x and the y together. Now remember, the number that goes to the outside of the radical comes from the bottom, right? If we look back, the number on the outside came from the bottom of the fraction in the exponent. So our first job is to look at that 2 and 3 in the bottom, right, in that denominator position of those fractions in the exponents. We need to get them to be the same number. So that's going to be our first step. So x to the power of something, y to the power of something, the smallest number that 2 and 3 both go into is 6. So next, let's simplify. 2 times what is 6? Well, it's 2 times 3, so I'm going to do the same thing to the top and the bottom. And 1/2 becomes 3 over 6. 3 times what is 6? 3 times 2, so I'm going to do the same thing to the top and the bottom. 4 times 2 is 8. Now, this next step is critical. Okay, so when I rewrite this, I have x to the 3 over 6. Now, because I have y to the power and my number on top, 8, is bigger than the number on the bottom, 6, I want you to think about it as that's the same thing as y to the power of 6 over 6 times y to the power of 2 over 6. So this part here gives us some good review of exponents, right? That y to the power of 8 over 6, I'm going to rewrite this for us to really make sure you understand, is the same thing as y to the power of 6 over 6 times y to the power of 2 over 6. And remember that that's correct because if you are multiplying and you have the same base, you are supposed to add the exponents. So this is just y to the 6 over 6 plus 2 over 6, which guess what, is y to the 8 over 6, which is exactly what we wanted it to equal. So bringing in those rules from exponents and knowing that y to the power of 8 over 6 can be rewritten as y to the 6 over 6 times y to the 2 over 6 is the critical part of this question. The reason is that once I have y to the power of 6 over 6, well, 6 over 6 is just 1 over 1. So I basically can then pull that y to the front, and then I have y times x to the 3 over 6, y to the 2 over 6. Now what I can do is leave that y to the outside and rewrite in radical form. Remember, the number on the bottom goes to the outside, so I'm going to have y times the 6th root. Remember, the numbers on top are the ones that stay in with the radical, x cubed y squared. So here is my final answer, which looks like it is option D. Let me just double check. Y times the 6th root of x cubed y squared. Yes, the correct answer is D. Again, this question was the hardest one in the section. So I really want to make sure you know this is as hard as solving with radicals and exponents can get. First, you had to make sure that you knew those rules about how you can rewrite between radicals and exponential form. You had to review your rules of combining fractions, knowing that you had to have the same denominator, and how do you do that? And lastly, kind of this core rule over here, that y to the power of 8 over 6 is the same thing as y to the 6 over 6 times y to the 2 over 6, because again, when you are multiplying with the same base, it's the same thing as adding the exponents, right? We review that with exponents, but it can creep its way back into questions about radicals. So exponents and radicals are always going to go hand in hand, back and forth. You have to be comfortable with all of the rules for both. Super frequently tested concept on the SAT and on the ACT is f of x, right? They love asking you to solve for f of x and to solve composite functions. So we're going to do 3 questions together on this concept, medium and hard level of difficulty. So for this question, they've given us 2 tables. One is for f of x, one is for g of x, and they are asking us to find f of g of 5. So the first thing I want to make sure you remember is when you have a composite function, right? When you have a function inside another function, you always want to start with the inside. So the first thing we're going to do is solve for g of 5. Now I want to make sure you know what in the world is g of 5. So g of 5 is basically asking you, what is the value of g of x when x equals 5? So what you're going to do is you're going to look at your g of x table, right? So here are values of g of x based on given x values. We want to know what is the value of g of x, so this column, when x equals 5. So when x equals 5, what is g of x? Well, the answer is -7. That means that g of 5 is -7. So now a question that asks us to find f of g of 5 is really just asking us to find f of -7. And that's because g of 5 is simply -7, right? We just figured that out. G of 5 was -7. So again, we start with the inside so we can basically solve for g of 5 and then ignore it and replace it with whatever it equals, which in this case was -7. So now we're going to find what is f of -7. Well, just as we did for the first one, I want to make sure you know what does that even mean. If they ask you for f of -7, they're asking you what is the value of f of x when x equals -7. So here's my f of x column, and I want to know what is f of x when x is -7. Well, here my x value is -7. And what is my answer? What is my value of f of x? It's 9. So the correct answer is E. Second question on f of x and composite functions, also asking us, right, to put a function inside another function. What is g of f of x? Now, what makes this question more challenging is on the prior one, we had a number here. Let me erase it for us, right? We had f of g of 5. Now we're being asked, what is g of f of x? So instead of having a number here, we still have the variable x, which makes it a little bit more complicated because we're still going to have x in our answers. Now, what this is telling us to do is to take f of x and plug it in to g of x for x. So what does that even mean? That means I'm going to take my core expression for g of x, which is right here. So g of x is x squared plus 2. So think about it. If I was asked like for g of 3, I would do 3 squared plus 2, right? Whatever you have here, you put here. But instead of x, I actually have a function. It's asking me to find g of f of x. So what I'm going to do is everywhere that I see an x, I'm going to put an f of x, right? So what I did is instead of having x squared, I have f of x quantity squared because that's what I'm plugging in. Well, f of x is just x plus 4. So to solve for g of f of x, I'm going to replace f of x with x plus 4, square it, and then add 2. So that is how I'm going to find my final answer. So now this is fun because we get to do a little review of FOIL. X plus 4 squared is just x plus 4 times x plus 4. Do not forget the plus 2 at the end. Let's go ahead and FOIL. F stands for first, x times x is x squared. O stands for outer, x times plus 4 is plus 4x. I stands for inner, 4 times x is plus 4x. L stands for last, 4 times 4 is plus 16. And then do not forget the plus 2 at the end. So our final answer, we're going to get to review how to combine units. Take everything with an x squared and combine it. We just have the 1. Take anything with an x and combine it. 4x plus 4x is 8x. Take anything that's just a number and combine it. 16 plus 2 is 18. So our final answer is x squared plus 8x plus 18, which is C. So again, as we go from our first to our second question in this f of x and composite functions review, notice that we did the same thing, right? We took some sort of value. In this question, it was f of x. In the prior one, I think it was g of 5, right? The first thing was to kind of start with that inside part, plug it in to whatever the expression is, and then solve. Okay, so for our last question on f of x and composite functions, this one was kind of right as the questions were transitioning from medium to hard. So the question is saying, what is f of 6? F of 6 is basically saying, what is the value of f of x when x equals 6? Now, if we look carefully, we've actually been given 2 equations for f of x. We have this one and this one. So the question is, okay, shoot, which one am I supposed to use, right? I know I'm supposed to plug in x equals 6, but am I supposed to plug a 6 in here or a 6 in here? Well, the answer is that we need to use our second equation for f of x. The reason is that the first equation only applies for values of x that are less than 6, right? So that domain restriction of basically saying, hey, use this when x is less than 6, well, that means that we could use it if x was 5 or 4 or 5.9999999, but they're actually asking us when x is 6, so we cannot use that first one. We have to use the second one because there they tell us that's the expression to use for values of x that are greater than or equal to 6. So because it's greater than or equal to 6, that's the one we're going to use. So we know that f of x is negative 1/2 x minus 3. So we want to know what is f of 6. Again, what that means we're going to do is anywhere we see an x, we're going to put a 6. So that becomes negative 1/2 times 6 minus 3. Negative 1/2 times 6 is negative 3, minus 3 is negative 6. So the correct answer is A. F of x and composite functions come up all the time on the SAT and ACT. So it's critically important that you know how to look at something where it asks you what is f of 6 and that you know what is that actually asking me. That's why I went through the time of actually writing down what it means, because I think for a lot of students that's where they struggle, is they don't know what f of 6 is even asking them to find. Whenever you have word problems that are kind of describing real life algebra scenarios, right? We kind of have these linear systems word problems, these word problems where you have to create some sort of equation or expression to be able to solve. So what I always encourage students to do is when you see a question that has a lot of words, I want you to take notes as you read. So what do we know in this first question? It says that Ava earns her regular pay of $16 per hour for up to 40 hours of work per week. So I'm going to take a note to myself that for the first 40 hours, she is earning $16 per hour. For each hour over 40 hours per week, so anything that is greater than 40 hours, Ava earns 1.5 times her regular pay. So she gets 1.5 times that $16 per hour. How much does Ava earn in a week in which she works 48 hours? Okay, so if we need to kind of figure out what is she going to get paid for working 48 hours, we know that for the first 40 hours, she's going to get paid $16 for each of those hours. Plus for the next 8 hours to get from 40 to 48, she's getting paid 1.5 times her regular pay. So if I come back up here and I do 1.5 times 16, I see that at that time she gets paid $24 per hour. So she's going to have 40 hours at $16 an hour, and she's going to have 8 hours at $24 an hour. So the total amount of pay she's going to get 40 times 16 is $640, plus 8 times 24 is $192. And when I add that together, I see that Ava makes $832 in that week. So the correct answer is D. Now we're going to do one more of these example questions. Again, remember these linear systems word problems, they're going to give you a word, a word problem, lots of words. You have to figure out how to take the key information, create some sort of expression to solve. To produce aluminum bats, it costs the baseball equipment company $3,800 for overhead. Okay, so this company has just a flat fee of $3,800 that they have to pay, plus, so do a plus sign, $3 per bat produced. So it's going to cost them $3,800 plus $3 times the number of bats that they make. What is the most amount of bats that they can produce? So what's the biggest number that I can have here for $20,000? So if I create this expression, right, it's going to be, I have $20,000 total. And basically with that $20,000, I need $3,800 for just that flat overhead fee, plus I need $3 for each bat I make. And the question is, what is that value of B? How many bats can we make for $20,000? So the number of bats I'm just going to define as the variable B. So I have $3,800 plus 3 times b equals 20,000. Now this just becomes a combining units problem where we need to get b by itself, so I'm going to subtract 3,800 from both sides. And I get that 3b equals 16,200. To get b by itself, it's being multiplied by 3. I'm going to do the opposite and divide by 3. And I get that b equals 5,400 bats. So the correct answer is D. These types of questions come up a ton on the SAT and ACT. So again, just remember, break them down one little bit at a time and create those expressions to reflect the information provided in the question. To review sequences, I've picked this one question that I want us to do together. Now this question is asking us about geometric sequences, so we're going to review that. But in the process of reviewing geometric sequences, I'm also going to make sure you know the key rule for arithmetic sequences, so we're going to kind of get to review both in this one question. So what information do we have here? It says that the first term in the geometric sequence below is -6. So here's our first term, -6. Here's our second term, third term, fourth term, fifth term. If it can be determined, what is the sixth term? Okay, so look at that. They're asking us to basically tell them what is the next term in this sequence. So here's the review that I wanted us to do. In a geometric sequence, between each term, you multiply or you divide. In an arithmetic sequence, I'm just going to kind of write this note over here on the side. If it had been an arithmetic sequence, in between each term, you add or subtract. So that's kind of the key difference between arithmetic and geometric sequences. So if we look at our numbers, -6 to 12, 12 to -24, -24 to 48, etc., you have to think to yourself, well, if they tell us it's geometric, then we know that in between each one, we have to multiply or divide by the same number. So how do I get from -6 to 12? Well, I've gone from a negative to a positive, so for sure I'm multiplying by a negative number. To get from 6 to 12, that's multiplying by 2. So -6 to +12, I multiply by -2. Guess what? 12 to -24, that's also multiplying by -2. -24 to +48, also multiplying by -2. 48 to -96, also multiplying by -2. So to get from my fifth term of -96 to my sixth term, which is what I'm solving for, I will have my fifth term, which is -96, times that common ratio, right, that common number I was multiplying by, which is -2. So my sixth term is -96, again, my fifth term there, times -2, which is equal to +192. So the correct answer to this question is C. And it was great because even though we did one question with geometric sequences, it also gave us this great opportunity to also review that if they had told us in this question that it was an arithmetic sequence, then in between each term we would have needed to find our common D, that common difference. What am I adding each time or what am I subtracting each time? So again, with arithmetic sequences, you're finding that D, that difference, what you're adding or subtracting between each term. With geometric sequences, you're finding that common R, that common ratio, where you're multiplying or dividing between each term. Okay, so that wraps up our review of these core concepts, these top tips for the math section with algebra-related questions. I hope you've been able to take great notes. I hope that everything that we reviewed has kind of started to click really well for you so that you're growing your content knowledge and growing your skills and growing your confidence so that when you see these types of algebra-related concepts on your upcoming SAT or ACT, that you feel really comfortable tackling those questions. Now, always feel free to subscribe to the Winward Academy YouTube channel because we do have tons of these types of videos that provide great support and example questions and review to really help you feel more comfortable with these exams. So again, thank you so much for joining and participating because I know we went over a lot of math. So thanks again for being a part of it and look forward to doing more again.